Hi, my name is Sachin Date. My specialty is in enterprise and cloud-based software. I've written this article to help people decide what is the best strategy to copy their big data into the cloud. If you wish to upload data into the cloud, you basically have three ways to go about it. You could upload it over the internet using your internet service provider. You could also copy it into a set of drives, and these drives could be solid state drives or hard disk drives or tape drives, and then ship those drives to the cloud provider. Or, if your data is already in another cloud, you could also use the APIs provided by the destination cloud to move data from one cloud to another cloud. So let's take a look at the first option, that's uploading your data over the internet. Let's say you have 1 terabyte of data to upload to the cloud, and your ISP provides you a 100 megabits per second sustained upload speed. Now that sounds like a pretty good upload speed, right? Well, it turns out that you'll need just under 24 hours to upload 1 terabytes, and that's assuming your connection never drops or slows down. But what if your data size is 5 terabytes, or 10 terabytes, or 100 terabytes? As you can see, a straight upload of big data over the internet can take just far too long to finish, even at a 100 megabits per second upload speed. So let's look at option 2, that is copying the data into a set of drives and then shipping those drives to the cloud provider. It turns out that you can express the time that you would take to move data in this manner using a neat little equation like so. In this equation, the data transfer time is effectively the sum of the time required to copy data into the storage appliance, the time required to copy data out of the storage appliance at the destination, and then the shipping and overhead times. Using this equation, if you plot the time required to move data into the cloud, the graph would look something like this. Notice that we have made some assumptions here. We have assumed that you are copying data in and out of 160 megabytes per second LTO6 tapes. We have also assumed that shipping time is 16 hours and overhead time is 48 hours. With these assumptions, if you compare the shipping time with upload time at 100 megabits per second, you'll notice that shipping the data becomes faster than uploading it at 100 megabits per second for data volumes as low as 4 terabytes. But what if you had a faster means of uploading data? For example, if you had a Google Fiber connection that lets you upload at 800 megabits per second. And also, what if you had a faster drive array available, say something that lets you copy data in and out at 320 megabytes per second. So here's a comparison between these two modes of data transfer. You can see that in this scenario, the inflection point has moved up to 59 terabytes. That is, as long as the content to be copied is above 59 terabytes in size, it will be quicker to ship it than to upload it. Finally, a word about cost. You see, LTO6 tapes at just over a cent per gigabyte provide one of the lowest cost to storage ratios. However, it's easy to see that both the weight and cost stack up pretty quickly as the amount of data to be copied increases. So to wrap up, the strategy you use to move big data to the cloud will depend on the size of the data, the sustained internet connection speed that your ISP can offer, if you're looking at uploading the data, the maximum sustained drive-to-drive copy-in copy-out speed that your drive setup can provide if you're looking at shipping the data to the cloud, the monetary cost of data transfer, and then to a small extent the shipping cost and transit times.